Everyone, myself M.R.M.RAJAKUMAR, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. In this video lecture, we are going to discuss about the pure substance and course outcome. After studying this subject, students can be able to evaluate the properties and of steam through steam tables and Mollier chart. The properties of fused substance include steam and formation and its thermodynamics properties, pressure, volume, pressure, temperature, temperature, volume, temperature, entropy, and enthalpy and entropy diagrams, and PVT surfaces and Raynaud's fraction and calculation of work done. These are the topics we are to discuss about in this chapter. So, what is the meaning of pure substance? So, a substance that has a fixed chemical composition throughout the system is called a pure substance. Water, hydrogen, nitrogen, and carbon monoxide, for example, are all pure substances. A pure substance can also be a mixture of various chemical elements or components as long as the mixture is homogeneous. Air, a mixture of several components, is often considered to be a pure substance because it has a uniform chemical composition. A mixture of two or more phases of a pure substance is still a pure substance as long as the chemical composition of all phases is the same. A mixture of ice and liquid water, for example, is a pure substance because both phases have the same chemical composition. Okay. This is the formation of steam. So before that, we should know what is the meaning of steam. So when we provide continuous heat to water, then at 100 degree temperature and 1 atmospheric pressure, it boils and changes its phase from liquid to vapor. This vapor is known as steam. Steam contains more energy as it has both sensible heat and latent heat of evaporation. Steam has been a popular mode of conveying energy since the industrial revolution. Steam is used for generating power and also used in process industries such as sugar, paper, fertilizer, refineries, and petrochemicals, chemical, food, synthetics, fiber, and textile. The following characteristics of the steam make it popular and useful to industry: higher specific heat and latent heat, higher heat transfer coefficient, easy to control and distribute, cheap and inert. So, the above this diagram, the formation of steam is before going to the formation of steam. Let we understand why steam is being formed or produced at constant pressure. The boiling temperature is 100 degree. We know the we all know the boiling temperature is 100 degrees centigrade at one particular pressure, that is 1 atmospheric. Now if we change the pressure, then the boiling temperature also changes. Since both are directly proportional, then if we decrease pressure, boiling temperature decreases, vice versa. The TH diagram, this is the TH diagram, that is temperature versus enthalpy diagram. It includes the information, the how to formation of the steam at constant pressure. We can explain now. So after having understood the temperature and the pressure fundamentals, let me discuss how are going to produce the steam from 1 kilogram piece of ice. Suppose the initial temperature of ice is a solid phase of water is minus 10 degree. Now keeping pressure constant, which is again assumed as 1 atmospheric, we provide continuous heat to ice. Let us understand what is happening in this diagram, that is graph. That the graph is plotted between temperature versus enthalpy. Let's start with point A, at which ice is at temperature minus 10 degree. Now as we provide heat to the piece of ice, its temperature as well as enthalpy increases simultaneously up to point B. Point B is at 0 degree, at which is the phase transformation of solid ice into liquid take place. This point is called melting point and temperature will remain constant until the whole transformation process is completed. That is, all ice will converted in liquid at 0 degree. This is so because of latent heat of fusion. All the heat we are providing is actually increasing the energy of the molecular of the water, not in temperature. Okay, that's why enthalpy increases but the temperature remains constant up to point C. Heat provided from point B to point C is hidden and cannot be measured using thermometer. Since we are providing continuous heat, the temperature and enthalpy both increases, that is sensible heating at D, which is boiling point of water. The next phase transformation, that is liquid to vapor, take place. Since the temperature again remains constant and enthalpy keeping increases, the heat absorbing during this is latent heat vaporization. This process goes up to E. At E we have converted at all liquid into steam. If we keep providing heat, then ultimately at F superheat steam is obtained. This is the formation of steam process. Then the important terms and applied to steam. First of all, wet steam. When the steam continuous moisture or particles of water in suspension, that is wet steam. Dry steam means when the wet steam is further heated and it does not containing any particle of water in suspensions, that is dry steam. Superheat steam means when the dry steam is further heated at constant pressure beyond the saturation temperature, that is a superheat steam. Then dryness fraction of or quality of steam. It is that define the mass of dry steam in certain quantity of steam to the mass of wet steam. There is a formula for the dryness fraction of means X equal to mg divided by mw plus mf. Then quality may have the value between the 0 and 1. Then critical point, it is the state beyond which there is no distinct vapor process. It is defined as the point at which the saturation liquid and saturation vapor state are identical. For steam, the critical temperature is 374.15. Then triple point means the PVT or TV diagram, the triple phase from the line called the triple line. The state on the triple line of the suspended have same pressure and temperature but different specific volume. You can see this image, the first diagram, the critical point is there. You can see this PV diagram. Critical point means there is a point joining in between the liquid and vapor line. Then triple line means the three lines, that is the vapor region, liquid region, solid region. The three joining place is the triple point. Okay. Then PVT surfaces. The pressure can be expressed as a function of temperature and specific volume. It is P into TV. Plot. This is the diagram. PVT. It's a surface called PVT surface. This figures PVT surface for substance such as water that expand on freezing level. Okay. The location of a point on the PVT surface gives the value of pressure, specific volume and temperature at equilibrium. The region of PVT, that is pressure, volume, temperature, surface, labeled solid, liquid and vapor or single phase region. The state of single phase is determined by any two of the properties, pressure, temperature and specific volume. The two phases region where two phases exceed in equilibrium separate. As the single phase region, two phase regions are liquid vapor, solid liquid and solid vapor. The temperature and pressure are dependent within the two phases region. Once the temperature is specified, the pressure is determined and vice versa. The state within the two phases region can be fixed by specific volume and either temperature or pressure. Then sensible heat of water or enthalpy of water. It is defined as the amount of heat required to convert 1 kilogram water at constant pressure from its freezing point to the temperature of formation of steam. The latent heat means already I told these diagrams. Then total heat of enthalpy of steam is sensible heat and latent heat. This is a combination of sensible heat and latent heat. Then total heat means the amount of heat required to convert 1 kg of water from freezing point at constant pressure into steam. The given dryness fraction equal to H equal to HF plus XHFG. H means enthalpy. Enthalpy of fluid means HF. Enthalpy of fluid and gas is HFG. Then one problem is there. So determine the condition of steam in the following case: at pressure of 10 bar and temperature 200 degree, at pressure 8 bar and volume 0.22 meter cube per kilogram, pressure 12 bar and 2700 kilojoule per kilogram is required to produce it from water 0 degree. So condition of steam at pressure 10 bar means 200 temperature means there is a, since the temperature is given 200 degree, this is a saturation temperature. Saturation temperature 179.9 degree. Therefore condition is given the steam is superheat. So the degree of superheat is 20.1 degree. Then condition of the pressure for 8 bar and volume 0.022 meter cube. From the steam table we can get the value Vg value equals 0.2403. From this value we can find out the X value. So dryness fraction 0.911. So the steam is wet steam. Then H equal to HF plus XHFG. From this value we get the X value for third condition. X value 0.958. This is also wet steam. So from this value we can take the HF value from the steam table corresponding to 12 bar. We get the HFG. So first condition is superheat steam, second condition is wet steam, third condition is wet steam. Thank you.